All right, this unit 2.5 has one more element, and I'm going to explain that element or elements, new ones, but it's just a composition of what you learned at the beginning of this unit. As you might remember, the way we graphed an interval or the solution of an inequality was using the arrows, right? Let's say that if I wanted to graph x greater than or equal to 1, I know that this is my reference point, and I'd say, well, because of this inequality, I start using a dot because it's a closed interval. It means that the solution includes 1, and then this is going to be an arrow pointing at the right. All right, and then you could see this type of arrows that had no end to the right or to the left, basically. But when we talk about compound inequalities, we could see a composition of something like this. You might see an arrow starting in this case I would say, let's say, a segment that has a starting point but no end. But we could also say, let's say, that the characteristics that we are defining in the solution set of an inequality is all the numbers that are greater than or equal to 1, indicating this segment as the solution. And also, you could start with this point right here and then pointing at the left, right? So with that in mind, it means that you are now going to describe two of them, which means you have this inequality using this arrow, but now we have to describe this arrow as well. And that's going to be it, yeah? So this arrow is describing all the numbers. The solution is going to be for the numbers that are less than or equal to -1. So it means like we are going to do 2 instead of 1 solution sets. Although, don't forget about this. You might have open intervals where you have the circle in case that we do not use the equal part of the inequality. That's one type of compound inequality that has both segments, looking the contrary directions. But also, you might have a different situation that goes like this. Let me explain. You might have a situation where the solution set is going to be within a closed interval, right? Like this, for example. The solution might be something like this, and you will see a lot of examples. Let's say that the solution set is just within this section. So what we do in this case is the following. I'm going to take a look at the endpoints, right? I mean, the starting point right here and the endpoint right here, which means that the solution set now is going to be confined in between these two endpoints, right? So now I know, or I can say that I started at -1 and I ended at 2, and I know that -1 is the lowest part or the lowest number of the interval, whereas 2 is the highest one. That's it. So I can say that the x, for example, in this case for 2 is less than or equal to 2, as you can see. But at the same time, -1 is just less than x. Remember, this is an open interval or the dot. And that's how I describe another situation. This is another way of describing compound inequalities. Hope it works. All right. In the next video, I'm going to solve an exercise, and eventually we will come up with a segment like this or with rays. Yeah, and I had to specify that the first ones were rays, not segments. We might end up with a solution like this or with opposite rays, right? Okay, see you in the next video.